Hello and welcome back. Jake! Excellent, lovely to have you guys on board again. Superb. This is chemistry, MEL Chemistry, and this is copper. So my name's Dan. If you're new and I haven't seen you before, I don't recognise your names, you can live screen. So Kipling's Cakes. Do let me know where you come from as you come in and introduce yourself. I can read your chat, so if you don't want to, this is a stream and it's a live stream, so if you don't want to make your facecam live so I can see you, then you please do put your names into chat and then I can interact you with in chat. So, it just makes it a little bit more popular. Hello Nesbitt! I know that sometimes people are signed on with their computers isn't necessarily their name, but hello Nesbitt! Lovely to have you on board, thank you very much. But if you're not happy with the screen or making your screen go live, then please just put your name into chat so I can say hello at least. That would be great. So cool. I'll just quickly stop that screen. Okay, right. For those of you who are new, I can see you obviously if you go live, but I can't hear you if you don't go live. And 3 times during the course of this webinar, Louisa, hello Louisa. 3 times I will stop and then ask to unmute. If you want to ask me questions directly, you can unmute yourself or we'll unmute you. All you've got to do is put up your hand and then you can ask me questions, etc., as we go through. Okay, Wendy. Hi Dan, this is Harrison from Newcastle in the UK. I've done lots of MEL experiments, but this is my first time live. Hello, well Wendy, thank you, lovely to have you on board. You can go live if you want. I'm Mark. Hello Louisiana, I'm Mark. And so just, yeah, whatever makes you feel comfortable, but if you'd like, it's nice to have a little bit sort of personal interaction and then I can see what you're doing and answer any other questions, etc. Cool, so without much further ado, ladies and gents, we are doing copper. So this is the copper set. Sorry, I think my camera's just gone a little bit out of focus. And I think we'll just put that up there, hopefully it'll focus on that copper. I'll just see if I can get it to focus a bit. So 3 seconds, let me dash out for a second. Back in focus? Maybe back in focus, not so focused. Sorry, my camera's having a little fun with me today, obviously, but it is the copper set. Blurry down, sorry guys, sorry. I know that, I don't know, hang on. Let's just see if it will, back in focus. Cool, right, so it's a copper set we're doing today. This is busy. Now I have to tell you, yep, that's the copper one, that's the one. Yes, Nesbitt, that's the one, yep, cool. So now, there's one thing I've got to explain about this copper experiment is that the last experiment, yes, nice one there, Jake, yep, fantastic. The last experiment actually does take 48 hours to finish. We're going to start it, we're going to do most of the chemical reactions, but you have to wait for part of the chemical product, which is what's called sodium citrate, to dry. Now that bit you're going to have to then do the following day, okay? But I will explain it, and I'll explain everything you do, and we'll get it all set up, so don't panic. Okay, cool. So without much further ado, let's have a look at the equipment that we need. So you need access to a lighter, but that's for later, okay? So this actually we're not going to use today, apart from lighting the candle, but you'll need that to light your sodium citrate tomorrow, okay? So first of all, we need the tray. You need your little tiny python. You need a candle. You need the pipette. You need a source of cold water. So cold water for the first experiment. So the first experiment we're going to do is this one. Okay, so the first experiment is why so blue. Okay, so that's the first experiment we're going to do today. You also need the little heating cooker from your starter kit. So heating cooker from starter kit. You need the chemical that we're going to use is the powdered, so just check it's the powdered copper sulfate, so powdered copper sulfate, okay. Now, we are not going to use gloves for the first experiment because we're going to heat source, okay, but we are definitely going to use our glasses, so say gloves and glasses. Then you need, the last 2 things that you need for this one are your spoon, so a little spoon, and also your spatula. You also need your lighter for this one, okay, cool. So without much further ado, I'm going to get my glasses on. And then of course what I'll do is we'll explain what to do. We're going to do this first of all, and then I'll explain some of the chemistry as well. Right, so if you just get your heating mantle set up like so. So open up your heating mantle. and then put your candle in the center of the heating mantle. Okay, put your candle in the center of the heating mantle like that. I'm going to put that to one side, and then we're going to light that. So just light the match. Hey Nisbet, I don't see you in chat. Connie, hi Connie. So light your candle if you can. My lighter playing hard to get. So light your candle. If you've got matches and you want to use a spill, that's perfectly fine. And then stick your there we go. Stick the little mount over the tray like that. Okay. Right, the very next thing that you do is you're going to take out some of the copper sulfate. So we're going to take some copper sulfate and put it into the pie tray. So what you want to do is 1 spoonful. So just take 1 spoonful of the copper sulfate crystals. So 1 spoonful, and put it into the pie tray. Then the next thing you do is give it a little shake so it's nice and evenly covered. So give it a little shake so there's an even layer of the copper sulfate on the tray. Now can you please note that the copper sulfate is blue. So this chemical is a lovely blue chemical, very famous blue chemical. Okay, so it's blue. Now what you then do is put it on top of your heating tray. Okay, and just watch what happens to it as the candle heats it. So just watch what happens there as the candle heats it, okay? So this might take about a minute or two, maybe 2 or 3 minutes. So just give that a couple of minutes. In fact, it might take a little bit longer than that, maybe about 10 minutes, depending on your candle and the position. But you should see within about a minute, you should see that part of that blue is starting to disappear, starting to change to white, okay? Is everybody okay? Everybody okay so far? Yeah. So this whole product, this whole box here, and I think if you watch it again, you can still see it's going white, ever so slightly white. Now we're going to leave that cooking for about 10 minutes, okay guys and girls? Going to leave that cooking for about 10 minutes. I'm assuming everybody else is okay. Just again to remind you, if you want to, you can go live. This is a sort of live meeting if you want, but don't panic if you don't have to. But do let me know in chat if everything's going okay for you. Right, so whilst that's cooking and it's going white and it's turning white, okay, and you can actually give it a little prod with your spoon, okay, you can give it a little tiny stir around. Give that a little tiny work around if you want. You don't have to, but if you want to give it a little work around, you can. Okay, so you can see it's going from blue to white. So let me just switch to the slideshow and explain a little bit of what's going on here, okay? Copper. So this is the copper set. And it's all about the element copper, of course. If I just... hopefully that will work. So this is the element copper. So it comes from that Cu Jimmy, actually comes from the Latin cuprum, which actually is after the country. The Greek for Cyprus is Caprios or cuprum, and that's where we get Cu from. Okay, so some of the elements have symbols that aren't necessarily the same, like it should be CO. If you see that nickel next door to copper, look, for example, is Ni, and that's just obviously nickel, so the first 2 letters of the name, but Cu stands for cuprum. Okay, and what we're actually doing here in this particular chemistry experiment, we're doing what's called a thermal decomposition reaction. So you see how the compound here, AB, actually then is turned to A plus B, so it's a thermal composition. Now the actual name for copper sulfate is copper pentahydrate, okay, copper 2 pentahydrate. And can everybody see this little dot? Can everybody see that little dot between the copper sulfate and the water? Yeah, cool. Well, that little dot is a chemical symbol for what's called water of crystallization. So that little dot you see here, look, stands for water of crystallization. So the water molecule is very lightly bound to the crystals, very lightly bound. Thanks, Jake. Thank you. It's very lightly bound to it's not massively strongly bound to the copper, but it's kind of a very fine kind of bond. And if you heat it, you can actually cause the water molecule to split apart. So then you've just left with copper sulfate, and then the water comes off obviously as steam. Well, not steam obviously, but as water vapor, okay? And as you look down at your thing now, it should be getting increasingly white, okay? So increasingly white. So thermal decomposition reactions are where you heat a substance and it splits apart and two different compounds can be formed, okay? Now we're going to talk about copper complexes a little bit later, and I'm going to come back to the copper in a second. How's everybody doing? Has everybody's gone quite white? Has everybody gone quite white? Yeah, cool. Nice one, Jake. Yeah, Connie, thank you very much, Connie. Yeah, just take a little thumbs up so I can see. That's really nice. And Levi, sorry, thank you very much. Yours has gone white too. Fantastic, lovely, jubbly, jubbly, jubbly. Okay, so, and Wendy, lovely, lovely. Thank you, Wendy. Cool. Nice one. All right, excellent, excellent. Right, so now we could wait until it went completely white. We could wait until it's going to completely white, but you can repeat this experiment several sort of times. So what we're going to do now is we're going to add water back to the white copper sulfate. So the water's been driven off mostly. And if you now add, let me show you how to do this. If I just switch screens again, where are we? I'll just go back to bird's eye view. Okay, cool. So if you can, you should have a screen, a little tiny bit of copper sulfate that looks like this, or it's copper sulfate. It's not hydrate, it's not pentahydrate here. If you blow out your candle, so don't touch the piter, just blow out your candle. Okay. If you now get your pipette, take up a full pipette of water and drop some of the water back onto your copper sulfate and see what happens to the colour. Just drop it, a couple of drops, and you should see, remarkably, that it's gone back to blue again. Can everybody see that? Has everybody done that? So your white copper sulfate has rehydrated. So the copper sulfate has re-reacted with the water to form copper pentahydrate, or copper sulfate pentahydrate again. Penta, of course, being 5 hydrates. So you've got 5 water molecules per copper sulfate. So you've actually reversed that reaction. And that's reversible all the time. So if you keep heating that again, it will go from blue to white, the water will come off, and you've got copper sulfate. Is that okay? So that's what's called a thermal decomposition reaction. Cool. Everybody okay with that? So why so blue? So, right, so let's crack on then. So another aspect of copper chemistry, and of course, copper is a really incredibly important, Connie, nice one, incredibly important element. The Smiths, fantastic. Excellent, cool. If I just pause for a second and just see if there's any questions. So if I'm going to pause, if anybody would actually like to ask any questions, all you've got to do is put your hand up and I'll answer some questions. All you've got to do is put your hand up and I will answer your questions. I will then unmute you so everybody can hear. Any questions? No questions? Okay, sure. Okay, so I see there's no questions, so we'll crack on then with the next experiment. Okay, so experiment number 2 is we're looking at something called copper complexes. And this is really pretty chemistry, okay? So if I'm going to move my heating mantle to one side. Now don't remove your heating mantle completely because we need that for the last experiment, okay? So we need that for the last experiment. So this is experiment number 2. So this is what we're going to do now. We're going to look at some pretty copper complexes, they say. So pretty copper complexes. So what you need for this one is your tray with 3 little tiny test tubes, your little tiny plastic test tubes, which you've got little volumetric measurements on the side. Now the chemicals that we need for this one are sodium disulfate. So sodium disulfate, you need some ammonium carbonate, you need sodium chloride, so salt solution, so standard salt solution. You need the copper sulfate liquid here. So if you look at that one, it's the copper sulfate liquid. Okay, So not the powder in this case. So we don't want the powder in this one. So put that to one side because we do need that for next one. So copper sulfate liquid. Okay. Right. So if you take out the tops, I'll just stop there for a second and just see if everybody's okay. Everybody okay? I'm assuming I can only see sort of two screens and there's nobody chatting to me, so I'm going to see. Connie says yes, thank you, Connie. Even a small thumbs up. Levi says yes, Connie says yes, fantastic. Okay, guys, then we'll crack on. Okay, cool. So if you just take the lids off your little test tubes, your little vials, so little measurement vials, so you just take the lids off there like so, and you'll notice on the things that there's a little tiny here. So you've got 1 mil, 2 mil, 3 mil, 4 mil, 5 mil measurements. Okay, so this is important. Okay, so in the first one, now we may have to take the safety plug out of each one of these things. So I seem to have misplaced my little pin. But if you take the safety seal out of this, you'll notice that in the top of all of these little containers, reagent bottles, there's a little plug. So we need to take the plug out of all of these bottles, okay? Now I've lost my pin temporarily, so I'm going to scuttle off and go and get that. Oh, here we are. There, I found it. Very good. So depress the little plug out of all of your little safety seal out of all your little reagent bottles. So this is the sodium disulfate. And then here I have my copper sulfate. So just depress the little plug out of that one. And then it's a good idea, guys and girls, it's a good idea to just clean the little tiny top of your paper clip. So if you've got a little bit of, a little tiny bit of paper towel, just clean the top of your paper clip. So just depress that then like so, so you're not contaminating the containers each time. And again, as you probably noticed, that some of them are a little tiny bit stiffer than normal. And then last one here for me is the ammonium carbonate. So just pop that out like so. Okay, cool. Right, at this point, you should get your gloves on. You should have had your gloves on beforehand, and I should have remembered to tell you to have your gloves on beforehand. Now, for the first one, you're going to put 1 mil of the sodium disulfate. So 1 mil of the sodium disulfate in test tube number 1. So 1 mil. As I said before, look, can you see the bottom? It says 1 mil. So that is, so fill up your test tube with 1 mil of sodium disulfate. So 1 mil there. Okay, so let's just do that. So here's my sodium disulfate. So 1 mil there. A little bit more, that's it, perfect. So 1 mil of that, and then put the lid back on. And now the next one, you want sodium chloride, 4 mils in both. So you're going to put the sodium chloride, into the one you've just added to. So top it up to 4 mils. So the one you've just added to, so top with sodium chloride up to 4 mils. Okay, like so. So this has topped up the sodium disulfate with sodium chloride, okay? So top that up to 4 mils. Then in test tube number 2, you're just going to put sodium chloride solution. So in test tube number 2, it's just sodium chloride solution up to 4 mils. Okay, so there we have it. So 4 mils of sodium chloride solution. Everybody okay so far? And then the last one then is the ammonium carbonate. So ammonium carbonate, and that's in test tube number 3. So again, you want 4 mils of that. So 4 mils now in each one. So 4 mils now in each one. And then put the lid back on that one. So last but not least, now we've got our source of copper ions. This is our source of copper ions, okay? And this is what's going to form our complex. So in chemistry, and I'll explain that in a second, these are called complexes, okay? Now for this one, you're going to top them up to 5 mils. So each one of these test tubes, you now top up to 5 mils with copper sulfate. So just top that up to 5 mils with copper sulfate. And you should see some really beautiful colours then appear. And there we have some really beautiful colours. If you put the lids back on, you can give them a little shake. So put the lids back on and give those a little shake. And you've got some 3 beautiful little coloured test tubes, hopefully. You can just give that a little shake. There we are, perfect. And then this one. And then finally this one. So has everybody got 3 wonderfully beautiful coloured copper complexes? I hope so. Everybody okay? Hopefully it's all gone quiet. Everybody's busy complexing. And Levi's got a little... hey, Levi, thank you very much. Cool, cool. The Smiths, fantastic. Excellent. Lovely jubbly. Right, then in which case, whilst the rest of you are doing it, Harrison, lovely, fantastic. I will explain a little bit of the chemistry that's going on there, okay? So, what's a copper complex? Well, basically, the copper... It's not copper metal like you know, and we'll talk about that in a second, but it's copper ions. It's a charged atom. And in the ammonia carbonate, you see the blue one, the blue solution, the copper binds to the ammonium ions and it forms a complex copper-ammonium complex. So it's a big, complicated ion, a multi-compound ion, if you like, a compound ion. And when you put the copper in the sodium chloride solution, the chloride ions surround the copper and forms a copper chloride complex, okay? How are we doing, Jake? You're okay? Drinking in the lab, Jake, not allowed. So when you put the chloride, the copper sulfate into the chloride binds to the copper ion, forming a wonderful green sort of copper chloride. It's not quite copper chloride. And then the first one, of course, is the disodium disulfate. Now, what actually happens there, that's more complicated chemistry, but effectively, there's sulfur dioxide effectively binds to the copper, and there's a couple of those molecules, and it forms like a yellow complex. So that's the sulfur dioxide binding with the copper to form a kind of complex copper sulfate, effectively. Okay. Is that all right? So just a nice little piece of colourful chemistry, but looking at what are called metal complexes. Okay, I think the nicest one. Whose one's a favourite one? Which one's a favourite one? Anybody? You can write to me in text if you want, in the chat if you want, or you can put a hand up and I can ask a question. Yeah, that looks lovely. What a beautiful colour, Nesbitt. Yeah, lovely, absolutely lovely. I think the blue one's the nicest one. I love copper complexes with ammonia complexes copper ammonia complexes are really rather pretty. Cool. Okay, right. In which case, we'll crack on. So copper, it's pretty important stuff. So the reason we've got a copper box, look at some of the chemistry around it. And of course you've got copper pots, you've got copper coins. In fact, actually this one, 2013, there's nothing in that. There's hardly any copper in that one at all. But if you go back to 1983, and prior to 1983, particularly in America, in the UK, nearly all the copper coins were actually made of copper. But they changed that because the coins themselves are worth less than the actual amount of copper in the coin. So that had to change. Okay, can anybody think of anything else that's made of copper? Anybody else? There's no questions, there's no feedback. You guys are really quiet. Okay, so just a quick, then scootle on a little bit further. So copper actually occurs naturally in nature, unreacted. It does occur in lots of other copper compounds, but you can actually get raw copper in nature. So this is a copper nugget, okay? Because it's a very, very, very unreactive metal. You can make it react. One of the prettiest compounds you can get in nature, of course, is malachite. And that's really, really beautiful. And it's a hydrated or hydroxide copper carbonate. Okay, so that's the formula for that. And that's actually one of the ores of copper as well. We use that it's also for jewellery and all that kind of thing as well. So it's very pretty. So why is copper important? You might think that this element has got no other value, but it does. If you took away all the copper in your body, you'd die. So it's a really essential element. Absolutely essential for making your neurons work in your brain, for your blood vessels, for your bones, and for your skin as well. So copper is a really super important element. And actually, for most of us, get most of our copper, a lot of our copper actually through the food, obviously we eat. But also, when you're drinking water, all the copper comes through, all the water comes through copper pipes, and you get a lot of copper dissolved in the water, and that's good for you. as well. Okay, and the other interesting thing is, if in the past, and this was known for quite some time, is that copper itself has antimicrobial properties. So if you pour water that might have an odd bug in it, or some bacteria or viruses and stuff like that, into copper vessels, that actually acts to kill the bacteria. So they've got, and silver does the same thing. So metallic silver does the same thing, and copper and silver do work both the same way, in a kind of way of basically breaking up the membranes of those different creatures. Okay. Right, cool. Let's crack on. Well, good. Louisiana, fantastic. Cool. And I will just change slides and then we'll crack on then with experiment number 3. Okay, if I just then change that to bird's eye view. Right, so experiment number 3, just tidy this away. And then what we need for experiment number 3. So there's quite a lot of equipment for experiment number 3. So we need, first of all, we need some hot water. So we need some hot water. You do need your thing again, your lighter, your spill. I'm going to move that out of the way. The chemicals that we need for this one, I'll go through that in no particular order, and then we'll move that actually out of the way too. Now this is the experiment, guys and girls, that takes about 48. Wires, Harrison, yes, wires, indeed. Nearly all electrical wires are copper as well. Thank you, Harrison. Yeah, cool. So we need the sodium carbonate for this one. So this is the first chemical, so sodium carbonate. Everybody okay? I'll just quickly check back. Yep. So sodium carbonate. We need the copper sulfate again. So of course it's a copper experiment, so we need the copper sulfate. We need the citric acid. So we need some citric acid. So we're going to make some copper citrate. Jake, nice selection of complexes there. Lovely colours. Yeah, excellent. Cool. You need your heating mantle back again. So your heating mantle back again and the candle. Okay, and the top to your heating mantle. You need a little measuring, so we're going to use the measuring, the test tube here as a measuring device for this time round. Just put the lid back on those compounds. Okay. Right, we need your glass. You need the glass beaker, so the 150ml glass beaker. In the chat sector, everybody said, sorry, first time using Zoom. Harrison, no problem. Don't panic, don't panic, don't panic. Everybody sometimes it's new to using Zoom and stuff like that, so please don't panic. But you can type some questions into the chat, and then I can read those questions if you want, or you can ask Ash, who's the host for the Zoom chat, okay? Cool. Right, so where are we going? So we've got the copper sulfate, we've got our vial, we've got a glass beaker, okay? We also need your filter funnel. So we need the filter funnel. You need the conical flask from your starter kit. You need the filter paper. Okay, so filter paper. You need this. Now this will come later, okay? So this is the bit of the experiment that we'll do later, but I'll explain how to use it. And then you're going to have to do this a little bit later tonight, or then and also tomorrow. You need a stirrer, so a little bit of a stirrer. So there's a bit of stirring going on in this one. You need your scoop. And you also need a little tiny wooden scraper. So a little tiny wooden scraper as well. Okay. Is that okay for everybody? Right. In which case, we'll crack on. So hopefully everybody's got that. So I'll just give everybody a couple of minutes just to make sure they've got absolutely everything. Everybody's gone a bit quiet, so I'm assuming everybody's okay. Yep. You okay, Jake? Smashing. Okay, lovely jubbly, as expected. Excellent. Right, so first things first, what we need is 100 mil. So if we set up actually we'll set up our stove first. So we can put our, like that as well, just get that going for the time being. So just get that going. So light your candle, so light your stove again, okay, and then put your little tiny stove top onto the stove like so. It's a good idea to make sure the candle is positioned right above the middle of the hole, okay. Right, so first things first, we get 50 mils, so you want 50 mils of boiling water. So I'm going to use a flask, so 50 mils of boiling water. Sorry, 50 mils, so I'm so sorry. So yeah, 50 mils there of boiling water. So 50 mils of boiling water. So 50 mils boiling water. Put that on there like that. And then the sodium carbonate is the first chemical we're going to use. So sodium carbonate, and all of this goes into the beaker. So all of this goes into the beaker. So pop the whole of that. If you want to give the pot, the little sodium carbonate pot, a little tap first, just to make sure that all the powder's down, and then put all of that sodium carbonate into the hot water. So put all of that into the hot water, okay? And then give it a little stir, just help it. So just give that a little stir. So all of the sodium carbonate into the bottle. Right, so the next bit's important. The next bit's really, really important. So listen carefully. The citric acid, again, just give that a little tap just to free up. Sometimes it might be a bit clumped together. Just give it a little tap, okay? Now what you're going to do is you're going to add all of this bottle, but scoop by scoop, okay? Don't put the whole bottle in one go. It needs to go in scoop by scoop, okay? And you should realize one of the reasons for that. So put one scoop, look, at a time. So one scoop, and pour that into your sodium carbonate. And you should see a really gratifying little foaming reaction. And then another little scoop. So we're going to put the whole bottle in, guys and girls, the whole bottle in, but one scoop at a time. So what we're actually forming here is sodium citrate. So you can see that chemical reaction taking place with the citric acid and the sodium carbonate. So scoop by scoop, okay, so one scoop at a time. And slowly but surely we're forming then a nice complex of sodium, or compound of sodium citrate. So don't put the whole thing at a time. Don't put the whole bottle in at a time, otherwise it'll foam up clearly over everything else. Okay, and I think I've got down now to my last scoop, almost my last scoop. Indeed I have. So this is the last scoop of mine. So you want the whole bottle in, guys and girls. So the whole bottle in, and then just give that a nice big stir around. Okay, give that a nice big stir around. And remember to place, because this is really hot water, remember to place your thermochromic film, that little badge on the tea. So I'll just do that now, because we're going to heat up this container in a second. So put your little thermochromic film, and you can see, look, it's immediately gone hot. This container is hot. All right. How are we doing? I'll just stop there for a second, just to make sure everybody's okay. I could just stop there for a second. If I just get, is everybody okay? Yeah, everybody okay? Thumbs? Yep, cool guys, lovely, thanks very much. Yep, that was lovely, 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 cool. Right, so the next thing we need to do is we need to measure out some copper sulfate. So if you get your little tiny measuring, your little test tube here with the measurements on it, you want 5 mils of the solid, it's the solid copper sulfate, so 5 mils of the solid copper sulfate. So top that in. So you want 5 mils of the solid copper sulfate. And be quite precise with that, okay? And then you put this on top of your heating mantle and pop the whole of that 5 mils of copper sulfate into the sodium citrate and start to stir, okay? So put the whole of that 5 mils of copper sulfate into your sodium citrate and start to stir. Now guys and girls, this is going to take about 10 to 15 minutes, okay? This reaction takes a little bit of time to do, and you've got to get the temperature rising to help it along, okay? So keep that stirring. And you'll see in the bottom of your thing that some of the copper sulfate hasn't dissolved just yet, hasn't reacted, but it will do in time, so just give it a time. So while that's cooking, I'm just going to put the lid back on things. And don't forget that all these things can be recycled. All the empty containers can be recycled into the plastic waste recycling bin. So keep giving that a nice stir. Now this, again, ladies and gentlemen, some of this chemical reaction actually takes a little bit of time. It's a little bit slow moving, okay? Which is why we've got to have the heat source, the candle on underneath, okay? Levi into the waiting room. Yes, admit. Okay, cool. Right, so whilst that's cooking, I shall open up the floor to questions for the moment, and then we'll go on to a bit more of the chemistry. So keep stirring very carefully on that heat source. Any questions? So you can unmute yourselves if you want at this point. So what we're forming here, ladies and gents, we're actually forming a substance, a chemical compound called copper citrate. We added the citric acid to the sodium carbonate. You saw there was a foaming reaction, and so the sodium was reacting with the citric acid to form sodium citrate, that compound there. And actually, that's one of the compounds that you actually eat sometimes when you actually have, you know, one of those dib-dabs, is that sodium citrate. So they have a sodium bicarbonate and they react it with citric acid, and that forms sodium citrate as well. So it's actually some of the things you can actually eat. Don't do that, obviously, here. So keep stirring, and I said this does take about 10 to sort of 15 minutes, okay? So while that's cooking, any questions? Any questions? Again, if you want to put a question up, just put your hand up, and then we can unmute you. Harrison, Connie, Louisa, Lexi, the Smiths, Levi, I'm assuming everything's okay. Harrison, yep, cool, lovely. Is anybody's container going a slight green colour? Slight green colour at this point, hopefully. Which reagents did you use? I think we're missing something. Levi, yeah, no problem. Using the citric acid, so sodium citrate, citric acid. You use the copper sulfate, so 5 mils of the copper sulfate. You need the sodium carbonate, so sodium carbonate. And those are the three reagents. Missing citric acid. Levi, you're missing the citric acid. In which case that will not work. Have you, by any chance, Levi, have you got any, by any chance, citric acid in your larder? Do you cook, like if you cook Indian food or some tangy sort of Eastern food and stuff like that, they often use citric acid. If you've got citric acid in your cupboard at home, that will do. Harrison, still blue here? No, but it's on the grocery store canning. Yes, indeed, yeah. That citric acid will do the same job, perfectly fine. It might be solid citric acid. But if for this reaction here, instead of the liquid, because remember we supplied it, it is actually solid, you just need 7 grams of that citric acid and that'll be fine. Levi? Yeah, it does take a bit of time. It does take, but this particular reaction does take a little bit of time, okay? So I'm going to leave that cooking. Now, be warned, so this is part of the sort of chemistry, reality of chemistry. Sometimes it takes a little bit of time, okay? We can try again later using recording if it will be available. Yes, it will. Yes, the recordings, Levi, are available. Tomorrow they're uploaded on Monday. They'll be uploaded Monday, and so by Monday afternoon of next week you'll be able to see this sort of recording as well. When do we start seeing? Andrew. Now the crystals. This is where it takes a bit of time. So what we're doing here is we're forming a precipitate. We're forming what a complex called copper citrate. And copper citrate doesn't like being in solution, okay? Doesn't like being in solution. It wants to fall out of solution as a precipitate, okay? So once we've got that precipitate forming, now can everybody see that my flask is starting to change colour, look. It's starting to change colour. It'll take a couple of minutes to form. But what's actually happening, we're going to take out this precipitate, we're going to take that precipitate and we're going to filter it. And so we've got then a sort of damp filtrate in our filter paper. We're then going to just wash that. And what you guys have got to do then is put it on a radiator or somewhere warm and let it dry for about 24 hours. You've got to let it dry for about 24 hours, okay? But I'm going to keep cooking mine so that you can actually see what to do. All right? So it needs to be about 15 minutes. We've got about another 10 minutes yet to let that go, okay? Right, I just quickly nip back to the slideshow. and show you a few more useful, relevant bits to the chemistry that we're doing. Cool. So, and the first reaction that you saw reacted the sodium carbonate with the citric acid, and that formed sodium citrate, carbon dioxide and water. So when you saw that fizzing, well, that was carbon dioxide coming off, and you also formed some water. That's the formation of sodium citrate. When we added the sodium citrate to the copper sulfate, so this blue solution, so it takes a bit of time, just give it a little bit of time. I'm almost there. It's going to take about another 5 minutes yet. And I will swap back to my screen again so everybody else can see that. Okay, just keep stirring it, be patient, keep stirring it, be patient. So when you added the sodium citrate to the copper sulfate, what actually happened is the copper bound to the citric acid and forms copper citrate with sodium sulfate and water. Okay, so the metal ions swapped. Okay, so the sodium basically jumped out of the sodium citrate and formed copper citrate. Now the final point is, and this is for the experiment that you're going to do tomorrow when you've got some dry sodium citrate, copper citrate, is what happens to the copper citrate when you heat it. Now we'll have a look at that in a second, and let's just go back again to my screen. I'll just quickly do that. It's a bird's eye view. Okay, cool. If everybody can see this, look, can you see the bottom of my container? The bottom of my container, I've got like a gloopy kind of green gunge, a gloopy kind of green precipitate in there. It's like a kind of got a milky colour, and that is the copper citrate. That's the stuff that we're after. Has anybody got to that stage yet? Connie, Erin Dukes, Levi, the Smiths, Lexi, Louisiana. Has anybody got to that point? Jake, Nesbitt. Yeah, cool. Oh, I've got a question. Nesbitt, yes, hang on. I will just unmute you. Ask to unmute. Then you've got to unmute yourself as well. Nesbitt.
How much citric acid? We didn't have citric acid either, so we're putting it in.
Oh, you didn't have any citric acid in your box?
No.
Oh, Pat. Sorry about that. Have you got citric acid in your house?
Yeah, I've got it here. I just don't know how much to put in.
Oh, cool. About 7 grams. So 7 grams of citric acid is a very healthy teaspoon. Okay. It's a very healthy teaspoon. Don't dump the whole teaspoon in at one go. Put it in at about a quarter of a teaspoon at a time.
No problem.
Is that okay? You're very welcome. It's a pleasure. Right, so I'm just going to give that a couple more minutes, and we're almost done. A couple more minutes, and we're almost done. Again, a number of you said that you didn't have Jake here. Mine's gone milky. Jake, yeah, fantastic. If it's gone milky, keep going. Jake, that's perfect. It's absolutely perfect, Jake. So let's let it go for about another couple of minutes, and then we're going to filter that, and that precipitate, that milky kind of precipitate. And if you don't stir it for about 20, 30 seconds, you should see a greenish kind of chemical building up on the base. Levi, if we already have sodium citrate, do we really need citric acid? Is the citric acid really necessary if we're trying to make sodium citrate? We already have. Levi, what we had was sodium carbonate. So we made sodium carbonate. We then reacted that with citric acid to create sodium citrate. So you didn't actually have the sodium citrate to start. We had to make that. And then we popped in the copper sulfate, and the copper displaced the sodium and reacted with the citrate. So you form copper citrate. Asking because of the visual you just put up on the screen. Oh, sorry, I'm so sorry. Let me go back to the visual if you'd like. Jake, hopefully, if you just leave yours, you should see green precipitate now at the bottom. I'm going to lift mine off to show everybody. Hopefully everybody can see that. Can everybody see? That's what the bottom of your beaker should look like. This has been great. We have to go now. I'm so sorry, the Smiths. Lovely to have you. Thank you for subscribing. If you want a certificate from me to say that you've done this lesson, just hit the subscribe to the certificate, and I'll send a personalised certificate off to you to say that you've done this particular lesson. So hope to catch you later. Thanks ever so much. Enjoy. So here's what we're actually after. Look, I've got my little base of copper citrate. Look at the bottom of my thing. Okay, cool. Right, let me go back to the slides for Levi and everybody else, of course. Right, so slideshow. All right, so here, so we've got sodium carbonate and citric acid. So that's the sodium carbonate, look, and citric acid, and they react together, that foaming, fizzy thing, to form sodium citrate, carbon dioxide, etc. So that's sodium citrate we're forming. Then we take the sodium citrate and react it with copper sulfate to form copper citrate, okay? So what happens is these ions are explained. The sodium ion pops off the citrate and the copper ion binds to it to form copper citrate. Okay? And then we've got to now filter this, okay? So hopefully everybody's got to the same stage that I've got to. So now we need to filter this. So if you blow out your candle, just give that one nice little stir. Give it one nice little stir. Okay, so don't let the copper citrate bind to the glass at the bottom. Our kit doesn't mention sodium carbonate and citric acid. Levi, thank you very much for that, Levi. Could you please contact support at melscience.com? Levi, you must please type in support at melscience.com, and they will send you a new kit, okay? They will send you a new kit. I'm so sorry, Levi. Really sorry about that. Sometimes a kit, as with everything in life, sometimes you're missing a screw or a bolt or a nut or something like that. But if you write to support at melscience.com, they will send you a new kit, okay? I'm so sorry about that, Levi. And of course, this video will be available to you from Monday, Tuesday next week when you need it, okay? Right. So now we've got this. I've blown out my candle. So blow out your candle. And now we've got to filter this solution. So what you do is put your filter funnel into, just move that to one side, filter funnel into your conical flask, pull out one of the little leads like so. Okay, so put that into there, pop that into there. All right, now give this one a good stir, give your beaker a good stir, okay, and pour carefully into your conical flask. Don't pour it all in because it won't quite fit, but pour the majority of it in, okay? Pour the majority of it in. Then wait for that to filter out a little bit. And what's actually going to be filtered out here is the insoluble precipitate, the copper citrate. Nesbit, not sure what that code is. Okay, so then pour the rest of that in. So there we go. And you can see that green insoluble copper citrate, okay? That green insoluble copper citrate. Okay? Hopefully. I think everybody hopefully should be able to see it. I think that some of the kits are different. Nesbit, again, I'm really sorry about that, Nesbit, but if you please just write to support at melchemistry.com, they will send you a replacement kit. Okay? Yours came with sodium citrate. That's interesting. Okay, Nesbit, if yours came with sodium citrate, Nesbit, where are you on the screen? I can't see you, I don't think. I'll just quickly flick. Oh, Nesbit, sodium citrate. Ah, interesting. Not sure why that's happening, Nesbit. If yours came with sodium citrate, is it a solid or a liquid? Do you want, if you want to unmute yourself and just ask? Sorry.
Ours was powdered.
Oh, it's a powdered. Oh, right. If it's a powder, all you've got to do with the powder is add it to about 20 mils of water, about maybe 10 mils of water, and dissolve it. And then all you've got to do is then add the copper, the same amount of copper sulfate.
Yeah, we were confused at the beginning because our directions were different and we only had the two chemicals in this set. So, but we figured it out now.
Yeah. Yeah, so that was what confused you. I think, how could you get the soda? I haven't got that in this set, so fine. So the same thing, the reaction is basically, so I've got 3 steps in mine, you only have 2, which is perfectly fine. So the chemistry is the same. So you add the copper sulfate to the sodium citrate, you will get copper citrate, and then dissolve it, and then hopefully you'll get that kind of filter. Is that okay? Cool. That's what we're talking about. Excellent chemists. Right, cool. So the mine's almost filtered now. If you can see this now, we need, before we let this dry, now you're going to have to go away and let this dry on like a radiator or near a hot windowsill or something of that nature. We need just to wash that a little bit. And all you got to do to wash that is just rinse it a little bit with just water, okay? So just rinse that. Nesbit, that looks perfect. Yeah, that looks great. Colour, super, absolutely super. Cool. So all you got to do when you filter it, if you look at mine, so now nearly all the liquid has the filtrate there is the remainder, if you like, of the copper citrate is now in the filter funnel. So what I'm going to do just to wash it very slowly, very carefully, look, all you got to do is just with just normal water, cold water is fine, is just gently round the filter paper edges, just very gently. So you're flushing it all back down into the center of the filter funnel, into filter paper rather. Just give that a little wash with normal water like that. So you're basically allowing that solid residue to accumulate into the mouth of the filter funnel, so allow that to take place. Okay, cool. Right, whilst that's taking place, what I'm going to do is show you the final product. Because what you're going to do, if you look from your recipe cards, you will see that once you've got a powder, you need a really nice dry powder, and that dry powder you then need to put above on a. I actually used a radiator, a sort of normal radiator, and you need to turn that green. This is really important. Once it's dried, you put it on a radiator or above the boiling water in the flask, and I'll show you how to do that. Give me 3 seconds. Maybe 5. So in order to turn it from green copper citrate to blue copper citrate, you then pour boiling water into your flask. If you don't have a radiator, you can put this on over the next sort of 24 hours, and then just sit the little pie tin on top of the blue water. So that provides quite a nice heating base. And when this is dry, so I'll just take that out of the way. When this is dry, your copper citrate is dry, you then pump it into there and it will heat up, okay? And what you will get is this. So that's what you're ultimately looking for, okay? So I'm just going to pop a little bit. Actually, I'll just stop for a second. Has anybody got any questions? Is everybody okay? Anybody got any questions? I think everybody busy doing chemistry. Yep, cool. You all seem to be okay. No one's lost. Hey, fantastic. Levi, yay! Thank you very much, Levi, thank you. Okay, right, as I said, unfortunately I can't fast forward this, so you hopefully will have a nice thick blob of this green chemical. I'll bring it back up. This green chemical here is copper citrate, and it's thermally unstable, okay? It's thermally unstable, but it needs to be really dry. So you guys are going to have to dry this filtrate. I'm just going to give it one more little wash just to concentrate it a little bit in my filter funnel. Just give it one more little wash like so. And then I'm going to have to leave that one, a bit like sort of MasterChef or sort of BBC shows, or, you know, where they had, this is what I prepared earlier. So here is some of the green citrate I prepared earlier, and I've heated it to dry it out a little bit. And here it is my blue copper citrate. So this is blue copper citrate. And when you get yours to this sort of size, and it does take a bit of time to get blue, you can then experiment by igniting it, okay? Levi Sanford, would it be okay to put it in the oven with a light on overnight with a proofing bread? I wouldn't, no, not an oven. If you need because it might catch light in the oven. Nothing terribly is going to happen with that. Yeah, nothing really is going to happen. But what it might do is it might, because it's so hot or reasonably hot, is it might thermally combust. But maybe not. Actually, you might be okay with that. You might be okay with that. Right, so I'm just going to see what happens then when we set light to our copper citrate. If I can get my trusty lighter to light. So light it like so. And then what you're going to do is you're going to touch tomorrow. Unfortunately, guys, this is going to happen for you guys tomorrow. Is touch the copper citrate, and you should see this beautiful little sparkly look as it starts to combust. Isn't that beautiful? Hi, Jake. Can we just say what we do with the stuff at the filter paper? Yes. I'll just explain that. Hopefully everybody can see that really wonderful reaction taking place. I hope. And actually, as it reacts, you can actually see that it's glowing copper coloured, because that reaction, when sodium with copper citrate breaks down, it actually produces copper, then water, and a little bit of carbon dioxide. It's such a cool reaction. I love that reaction. And I created quite a lot, so it's really combusting really rather neatly there. Okay, just to remind you, Jake, sorry, and everybody else. So what's in here, this one here, now that you've washed it a little bit, you need to dry that. So you need to put that on a radiator somewhere or in a hot room and dry this out. So it'll take about 24 hours to dry. So if I just take that out like this, look. Okay. So just take that out, leave it in the filter funnel to be fair, because it's still a very, very sort of liquidy. Okay, take that out and put it somewhere nice and hot, like a top of a sort of radiator, until that's completely dry. And once that's dry, you then put that into your little cake tin here over hot water and make sure it goes blue. Now it might take a bit of time for it to go blue, okay? But this is a wicked, I think, hopefully you've seen that little sort of sparky reaction here, look. How cool is that? It's a really cool piece of thermally unstable compound here. Is that okay? Could you show us in tomorrow's lesson at the end? Yes, I can. I'll dry this out. So if anybody, I'm on tomorrow at 5, there's a 5 to 6 and then 6:30 to 7:30. If everybody wants to get their dry compound tomorrow, and make sure, again, please remind you, look, this one here, once you've dried it, you need to heat it again gently so it goes blue. So this colour blue, look, this kind of blue colour, it needs to go blue, not green, blue. So heat it again gently over your hot water. So heat it gently over the hot water in here. And then once it's blue, you can then ignite it. And it's really cool. Is this reaction old copper turned blue? No, Levi, no. But the reaction does produce copper in the tin. Is that okay? Is that okay, guys? And girls? If I open it up to chat, if anybody wants to ask me some questions, is copper used in fireworks? Levi, yes, copper is used in fireworks as well. Yes, it is, yeah. So all the different colours of the copper, basically flame tests, like magnesium always gives the white colour. You've got sodium produces that sort of orangey colour, that really orange sort of colour. Then you've got strontium to produce that really vibrant, beautiful purpley colour. Not purple, that's potassium, of course. Is that okay? How are we doing? Any questions? You can all open chat if you want. Sorry, great lesson, Jake. Sorry, I went not too well. No problems, no problems. I hope you're okay, Jake. Hope you're okay, and hope you recover quickly. And maybe I'll hopefully see you tomorrow. Any questions? You've been very quiet, you guys. What do you do with the flask? All right, everybody. So disposal. This one here, just this one go down the drain. So just pour that down the drain and wash it. Nesbit, jokes. Yes, of course, jokes. Right. Jokes. Let me joke for you. Give me a couple of seconds, Nesbit. Jake, yes, definitely see tomorrow down. Had to take one. Not a problem, Jake. I hope you're well. I hope recover quickly, please, and I shall hopefully see you tomorrow. So either 5 to 6 or from 6:30 to 7. And if you guys want to come tomorrow, I know we're doing different science tomorrow, but if you let me know when you come in that you've got your blue, remember your blue, where has it gone? Oh, misplaced it. Remember, you've got your blue copper sulfate, your copper citrate. Then we can do that from then, okay? Knock knock. So knock knock. Have an end on a knock knock joke. Knock knock. Anybody? Knock knock.
Who's there?
Ah, excellent. Wooden shoe.
Wooden shoe who?
Wouldn't you like to hear another joke?
Yay!
I got another one. My favourite knock knock. My favourite knock knock joke is.
Terrible joke. I loved it.
Knock knock.
Who's there? Who's there?
Europe.
Europe who?
No, thank you. No, I don't think I am.
Europe who?
But you're going to be telling that one to friends.
Okay.
Cool. Anybody else got any other questions? Oh, no problems. Well, I hope you've enjoyed it. I hope you've had fun. I hope you learned a little bit of chemistry. I hope that's been interesting for you. So I will love and leave you, and hopefully you're with me tomorrow. I'll see you tomorrow, either at 7, and then from 5 to 6, or from 6:30 to 7. So stay well. Harrison, should I put the filter on something? Just leave that, Harrison. If you just you can just leave that there. Put that into a little a glass if you want. You can take it out a little bit to help it dry out a little bit on a heater, on a sort of radiator, flat radiator. Nothing near a flame, of course. Just to allow it to dry out. And then tomorrow we're going to put that into this and heat it above the hot water. See, I've got boiling water in here. Okay. To help dry it out, to get it to this blue colour, because that's what we're after. We want to turn this green powder into a blue powder. Is that okay? Cool. In which case, thanks ever so much for subscribing to Chemistry. Sorry for some of you haven't got your kit and the wrong chemicals. If you could, again, write to support@melscience.com and they will send you a new kit. Levi, thank you very much. You're very welcome. So on that note, lovely. Thank you so much, guys, and I will see you next week.